So Pradyumna, today we'll see about access list and NAT. Okay. Okay. So ACL, what we have seen here as a key feature is inbound ACL and outbound ACL. Okay. So inbound ACL, what will do is it will actually filter the packets in the incoming interface. So filter outbound is outgoing traffic. So outgoing traffic is nothing but LAN to WAN, okay, from your end to internet or to the external network. Okay, that is outbound traffic. So it is going to filter before it leaves the interface. Which interface it is going to leave? Actually, it is going to leave the WAN interface, right? Inbound traffic, the incoming traffic, okay? So the incoming traffic is between WAN to LAN. That is incoming traffic. So that can also be filtered. So any incoming traffic, say from a source of a cloud server IP or from internet, a specific website on the internet, if you know the website IP address, and that can be filtered actually. Okay, so that specific IP address can be used as a deny statement before it enters the router. So that traffic is blocked on the interface level itself. That can be also done. Okay, these are the key features of ACL. Okay, now we have different types of ACLs. Okay, you aware about these things, or I can cover these things, or you already aware about standard extended named ACLs and all?
Yeah, cover it, ma'am.
Okay. So the type of ACLs, okay, standard ACL. Now, since you have asked, I think you have asked for the ACL to be covered, okay, as an extra topic. So I'm just covering. So that's why I was asking whether I'm just asking for your choice. Else I would have skipped it. Okay, so standard ACL, extended ACL, and named ACL. These are the three types of ACLs, okay? So standard ACL, it actually filters based on the source IP address. It is very simple statement, okay? Very simple allow statement or a deny statement can be applied. Example I can give, we need to give like a command IP access list. You need to give a number, any number, 10, 20, 30, or 10, 1, 2, 3, 4, any number. 0 to 99, I guess, is the number for 0 to, okay? 0, sorry, we'll start with 1. 1 to 99. 1 to 99 is the number we give for standard ACL. With the number itself, we can say it is standard or extended, okay? So IP access list, give a number, and then starts with a permit or a deny statement. So you're going to permit 10.10.10.0, the network, okay? And wildcard mask 0.0.0.255. So this means 10.10.10.network is allowed in that particular router. Okay, this is standard ACL, right? Extended ACL It can control traffic based on other multiple criteria like port numbers or specific host. You can specify a single host IP, okay, or even a single port can be blocked. Okay, for some set of network IPs, you can just block or allow a port, TCP port 80. Okay, that's used for a TCP connection or browser connection, HTTPS connection that uses some port. I don't remember now. I think port 80 is for HTTP and SMTP port 2025. Telnet, if you want to telnet some device for remote access, again, you can, that port is 23, that can be allowed or denied. So you can specify even the ports or single host in extended ACL. Okay, filtering can be done in multiple criterias, the extended ACL. So IP access -list. Again, the number given here, I don't remember, but it starts with 100, ends with some number. Okay. So starts with 101. Okay. Permit. Okay. Permit TCP. You can mention the protocol, but it's not mandatory. It is not required to mention also. But you can mention the protocol. TCP 10.10.0.0.255. Okay, this entire range. Okay, this entire range to the host. So in standard ACL, I'm just allowing one network or I can deny a network. But in extended ACL, since we can filter in multiple criteria, we can also use the port numbers to allow block and also a single host where we can mention source and destination. So this source to this destination. We can be more specific in allowing, in mentioning the source and destination also. So this entire range of network to a single host. Single host can be a server, okay, any server or any kind of server inside or outside network, okay, that can be allowed or denied based on the requirement. So that host equivalent Q. If you want to mention the port number, then equivalent to port number 80. So it's going to permit access. Okay. And here you can also put deny also. Deny TCP connection, then for this entire range, when it communicates to the host 10.1.1.1, it will deny the TCP connection which runs on port number 80. So this way we can make use of the extended ACL. Okay. Named ACL is simply instead of number, we are using the name. Instead of number, we can use a name here. IP access admin list, give a name. That is named ACL. So it's easy to remember for what purpose we are using it. Standard. Okay. Or you can use for telnet. Anything you can mention here like this. That is named ACL. And similarly, the other commands follows. Okay. So basically, ACLs are applied for applying for applying filters on the network traffic. Okay, you are controlling some traffic. You can apply controls. Without ACL, if you think that it's like everything is allowed. Okay, you are not going to enable routing, then it is denied. If a specific route is not enabled, then all traffic is denied altogether. And if you want to allow, then everything is allowed. So you want to control some certain level of traffic with the help of ACL. Okay. So it will actually improve the security, traffic control, and also like reduce the unnecessary traffic, improves the network efficiency. So it actually improves the security. So you can, if anybody asks you why we want to apply, or in what ways you can apply security on your network or on your router, what commands you will use to apply security. Okay, at that time you can mention on the router level, you can apply ACL, right? On the, once again. Okay, so where I left, yeah, if somebody asks you about how you will apply security on router level, you can simply say you can actually apply ACLs. But on the switch level, if you ask how uh, how security can be applied, but in various ways in switches, like you can also apply ACL on the switch. You can apply port security, okay, or you can apply spanning tree BPDUs, filter, those uh, those things and all you can explain. Okay, in the switch, there are actually, you can mention whatever, like we've gone through, no, about the port security, the inside spanning tree, you can apply spanning tree command on specific interfaces where you can deny access to specific host or specific device by sending BPDU packets or becoming a root bridge. You can explain those things on security part. Okay. So it is actually, it improves the security, it controls the traffic, okay, like allow, deny can be done. And it is also like it's going to reduce the unnecessary traffic. Unnecessary traffic to improve network efficiency. Okay. These are actually ACLs, basics of ACL. Now, let's go to NAT. Okay. Because in NATing, we are actually applying ACL for a NAT. So that's why I thought of like just give an overview about ACL and then start NAT. Okay. So NAT is Network Address Translation. Okay. So by the word itself, it is clear it is going to translate your IP address to another IP address. Okay. And it is going to used for a network traffic to from source to destination. Your communication is going to happen, but your network address is going to get translated to some other address when it is like getting routed outside the router. Okay, so why we want to go for network address translation? Okay, so when we are like actually contacting internet, okay, our IP address in the IP packet, okay, in the packet, there's an header information where our IP address will be there, added in the header. So when the packet actually goes over the internet, there are chances to hack packet, open, read what is the source IP address, okay. So our IP address is known by anyone over the internet. So what they will do, they'll try to send any traffic to our IP, okay, to infect our machine with malicious or virus or softwares, anything. Once if that is infected, what is going to happen? Then it's going to infect our entire network. If one PC in the if one PC in the network is infected by virus, then it is going to easily spread to all other machines. If all the machines are in the same network, definitely yes. Okay. So immediately, if at all, if you identify if some PC is affected, okay, by a virus when you are connected in office network or some huge network, then immediately you need to isolate your machine immediately so that the virus is not getting spread to the other computers. So immediately it will happen. It will immediately happen. It will make your entire network to go down. It will shut down your network. PCs shut down your network in the sense it is not going to affect your switch or router, but it's going to affect all the machines. It's going to affect your servers, which are all are Windows based or Linux based, all are operating system based, right? It's going to affect everything. So that means your network is down. But router switches will not be affected because router switches and all are running in a different operating system. So the virus is not going to affect your network devices, firewalls, routers, switches, hubs. Nothing is going to be affected. So, but router and switch has a feature, okay, for this feature for NATing, so that it is actually going to translate your IP address. Okay, so what happens here in the NAT is for one single IP, I'm going to, so I'm when I want to contact my internet, I'm going to change my IP when I get exit from my router. So my IP is 10.10.10.1. If I go out from the router, my IP will be 192.168.1.1. And I will get whatever the desired page from the internet browsed. Whatever I want, I'll get the information from the internet as 192.168.1.1. Again, when I come back to the router, my IP will be changed back to my original private IP, 10.10.10.1. And then I will just normally work as it is without knowing what's happening behind. So this translation is happen just to make sure the IP or the information, whatever is getting browsed or goes out of the router is actually safe and secure because your header information is changed. This is one thing. Another thing, in the place of NAT also, now we have a proxy server being used. Okay, so a server is placed, proxy server. So all your internet browsing traffic will go to that proxy server only, not to direct to internet cloud. No, it will go to your proxy server, whichever is hosted inside your office. It will go to the proxy server. And from that server, it will be connected through firewall and an exit interface going to the internet, to the outside network. So this proxy actually does this work. It is going to manipulate all the information, source information. So as if from the outside network, only the proxy IP is seen. Okay, and all the information, web pages information are getting stored in the proxy server and that is getting translated to the user. So user will not know who is sending the desired information, whether it's proxy server or it's direct from internet. User is least bothered about that because proxy server does all these functions. It is securing all the IP addresses being visible or transparent to the external network. Okay, that is again one way of securing the network. Okay, that is one method. And also, where exactly NAT can be used is, So anyways, we are going to use for network translation, right? So I have a public IP. I want to use that public IP for I mean, public IP is basically used to reach internet owner, right? Private IPs are going to be used within the local area network. So I want to reach internet. So I have an office, I want to reach internet. So obviously I'll purchase one public IP. Okay. Likewise, I cannot, what to say? I cannot directly reveal my IP, private IP to the public network. Okay. And at the same time, I have multiple hosts in a single network, say example 10.0.0.0/8. So how many hosts are there in this range is 16,777,216 hosts are there. So this many public IP addresses I cannot purchase for a net, right? So for each host, I cannot purchase public IP, right? For internet access, that is not possible at all. That is also very, very, very expensive. Even 192.168, 1.0/24. So this has 256 hosts. 256 IP address is again also expensive only. So that is not possible at all. So what I'm going to do is I'm going to translate, okay, my private with the public IP address, or in between I'm going to use a separate IP address to translate in the IP packet, okay, in order to reach the outside network. So outside network can be anything. It can be a different office, or it can be an internet, or any cloud server, anything maybe. Okay. So for that purpose only, NAT is used, not within the network. Okay, not within your local LAN. NAT is of no use. We are not going to use NAT within the network. When your traffic goes outside, at that time, NAT plays a major role in translating the IP information. Okay. So in NAT, there are key terms which you need to know. Okay. Inside local, inside global, outside local, outside global. Okay. So inside local, by the word inside itself, it is your actual private IP, okay, that is going to represent one or more device on the inside network. Sorry, it is the actual IP address assigned to the inside network, private IP, okay, private IP assigned to a device inside network. Inside network is your local LAN, private range. Inside global. Inside global, actually a public IP. Global itself is a public IP only. Okay, public IP that is going to represent one or more inside local IP. So one public IP is going to use as a representation for one or more private range IP. Okay, that is inside global. Global itself is public. So inside global is your private IP address. There is one public IP address which is going to represent the outside world. Right? That is the meaning. Now, outside local. So this is an IP address of the host which is outside. Okay, for an outside host. Okay, outside host in the sense it's going to be an IP address, okay, of an outside host that appears to the inside network. It's an IP address outside over the internet. Okay, that host as it appears to the inside network. How it is going, because it's local also, outside and inside. See, local and all are private, global and all are public. Okay, that's how you have to differentiate local, private, global, public involved. Okay, so now inside outside is what the traffic, which way the traffic is getting affected. That is inside outside. Okay, so the private IP address, the IP address outside host, it's going to be an outside host that is going to appear to be for the inside network. Okay, say google.com is a host, it's going to, how it is going to appear to your inside network, your private network. Okay, that is what is outside local. So that is nothing but IP address does not, it need not be reachable. Okay, it does not have to be reachable, but it is considered to be private, but must be reachable only to your inside network, inside local LAN. Okay, it should be reachable only from your LAN, not from, it is not necessary to be reachable from your home network or anywhere, but it should be reachable from your inside network because you have a routing which is already in place. Okay. Outside global is purely a public IP assigned to the host, on the outside network. So local is private, global is public, right? I mentioned, so it is a public IP to the host in the outside network, is not on your local LAN, it is outside network on the WAN. Okay. So this IP address is outside host. It is just a host which is outside the network. It is not public. It can be a public or a private, but it is outside. Okay. This is purely a public IP address of an host that is in the outside network. Is it confusing? You able to follow these terms? Pradyumna, are you there?
Yes, ma'am.
Pradyumna, are you there?
Yeah.
Okay, you are able to follow this?
Yes.
Oh. Fine. So these are the some important terms that you need to understand in NATing terminology. Inside local, inside global, outside local, outside global, right? So now let's see about different types of NATs that are available. Static NAT, hold NAT, and PAT, port address translation. So static NAT is where we are going to provide a one-to-one mapping. Okay. One-to-one mapping is done. So for one private IP address, one public address is mapped. So one local IP, one global IP is mapped. Okay, that is one-to-one mapping, static NAT. So 192.168.1.1, there's one public IP. 120.91.90.90 something. So 192.168.1.2 again. 163.150.2.2, some public IP. So for each and every IP, one public IP is mapped on a static NAT. That's going to be expensive. Just to reduce the cost, we can go for pooled NAT that actually provides again one-to-one mapping only. It's again one-to-one only, but one-to-one, okay. But what it is going to do is there is a pool of IP ranges, IP addresses. Okay. So in one-to-one, if I have a host of 256, then I need to purchase 256 IP addresses, public IP. Okay. But in pooled NAT, I need not go for 256. Okay. Instead, I'll go for 100 IPs, 100 public IPs. So my cost is reduced. So it was not in your office that all the time all the users will browse internet. No. Okay, only when there is a need, if they want to check something in the internet, they'll go check the internet. Otherwise, they are going to use their regular task of like creating some reports or working on some files or running some commands or scripts or working on some software, developing some software, right? Or checking some server health state or downloading a report from the server, working on the report, or some team managers, team leads are going to evaluate user their service performance. Okay, they're going to evaluate, they're going to teach something. So this is the normal, this is their normal task actually, right? They're not all the time, they're not going to browse the internet. So in that way, again, they can limit the usage of the IP address. So I go for pooled NAT. So pooled NAT, it's again one-to-one IP address is going to be mapped, but I have only 100 IP address instead of 256. So whoever comes first can able to reach internet. Okay. A connection will be established. Okay, so I have a pool of 100 IP. The first IP will be assigned to whoever comes first. Second IP will be assigned. And their session is going to be very short only, for a while, very short duration only this session will be live, right? Internet session. Otherwise, they're going to use their normal work. So at that time, there will be a NAT idle time, where once the idle time is over, that session will be closed, that TCP connection will be closed automatically, so that IP is getting freed for the other person to use. Okay. So in that way, you can go for a pooled NAT, okay, and still you can have use of the public IP addresses, okay, in one-to-one mapping method itself, right? Because unless if a user is not going to use any streaming website, only it will be continuously used. Otherwise, I'm searching something in the Google that is related to my work, right? I got the information in the Google. Then that page will be still open, but I'm not going to browse anything or scroll down or do something. I'll go with working on a different report. I have a doubt in a report with some term. I'm checking in Google, get that information, then I'm started to work on a report. So that session was kept live for some time, and then it is idle, right? So that TCP connection is closed. So my IP for the translation is also closed. That public IP is now freed up. some person, some other person who is in the queue can get used of, will be assigned with that IP. This is how a pooled NAT will work. Okay. PAT. PAT is port address translation. Port address translation, it is going to be many to one mapping. Okay. Many IP addresses can be mapped to one public IP with the help of the ports. Many to one mapping. Many to one mapping. Okay. So that means many local IP addresses, many local IP addresses can be mapped to one global IP or private IP. Okay. So this here actually you need to configure this in a router or in a firewall kind of a device where this mechanism, it works to identify different port numbers. Okay, so it can be used in a router or in the firewall device, Cisco firewall, a Palo Alto firewall, Checkpoint firewall, any firewall. Okay. But in firewalls and all, it'll be easy to configure. It is not like a router actually. All are GUI interface, graphical user interface. Okay, where is just you need to configure that device firewall with an IP with a subnet mask and make sure that is reachable over the network. It's live connected to a VLAN on a switch. That setup is more than enough. And other configuration and all, you can just take it in GUI, okay, in a web browser itself. You need not hit the command line for each and everything, but it's going to be very tough to configure firewall in that way. But GUI interface, a graphical user interface, will be very easy. Okay, you can just go to the browser, hit the firewall IP in the browser, the search bar, and a firewall console will open, and from there you will have many options to choose, select, add, and all. Very easy actually. Like how you used to configure a modem or home base or router or a home based modem. No, very easy. Those things is similar to that only. Firewalls and all are configured. So the NAT for port address, no, if you use a firewall, then it'll be very easy. Put the commands and all. Just add source IP. There'll be an option source IP. Enter source IP. Enter your source. Enter your destination IP or the NAT IP, which was the public IPs. To which port number you want to translate. Enter the port. That'll be very easy. But in the router, you need to enter syntax commands and all. This is different. So this NAT device actually is going to do what? Going to translate many private IP addresses, okay, to one global IP with the port number. So the port is unique. Here, the port we are calling as TCP port is unique. So ports like TCP 80, 23, 25, or 80, any port number. There are many ports where you're, for each and every connection getting established from your machine to internet, actually it has multiple ports. So for each connection getting established, it is working on individual port numbers. That port is getting opened. TCP connection is opened. Okay. So many IP 192, say 192.168 1.1 using one IP, public IP in port number 80. Okay. And same 192.168 1.2 device is also using the same public IP, but on a different port, TCP port number 25. Again, port number 50, or port 8080. So for same public IP, many TCP ports can be opened to allow access. That is port address translation. Okay, that way it is be more cost effective for any organization, and also in a more secured way your translation can happen over internet. Okay, these are the 3 types of NATs actually. So far you have any doubts in NAT?
No, ma'am.
Yeah, thank you.